So today we're going to continue with factorizing quadratics. Before we begin, I just want to refresh your memory a little bit on what is a quadratic and the important terms in a quadratic. So a quadratic, the standard form of a quadratic is ax squared plus ex plus c, right? This is the standard form of the quadratic expression. I'm calling it an expression because it's not equal to anything, right? So that means we cannot solve it, but we can factorize. Just like we can factorize any algebraic expression, we can factorize a quadratic expression. The thing that makes this a quadratic expression is this term in x squared here, right? In a quadratic, the highest power of x is 2. So any expression in which the highest power of x is 2 will be considered a quadratic. And in a quadratic, you have a, right? This is the coefficient of x squared, right? B, which is the coefficient of x. So these two are coefficients, right? A and B are coefficients. A being the coefficient of x squared and B being the coefficient of x. And then you also have a constant. So a constant is just a number by itself, right? A constant. So an example of a quadratic could be like 3x squared plus 2x plus 4, right? And in this quadratic here, a will be equal to 3 because that's the coefficient of x squared. B is equal to 2, that is the coefficient of x, and c is equal to 4, the constant, right? So in any quadratic, a, b, and c are real numbers, right? So a, B, and C belong to the real number system, and A cannot be equal to 0. The reason A cannot be equal to 0 is that, well, if you had 0x squared, then you'll have no term in x squared. And so the highest power of x will be 1, which will make the expression or equation, a linear expression, because in a linear expression, the highest power of x is 1. Right? So A, B, and C are real numbers, whereas A cannot be equal to 0. And all quadratics might not have a term in C or a term in B. For instance, you can have a quadratic that looks like this, x squared minus 4, right? And in this quadratic, x squared minus 4, A, the coefficient of x squared here is 1, right? And B is actually equal to 0 because there is no term in x. And then C is equal to negative 4. So in this quadratic, x squared minus 4, the A term, the coefficient of x squared is 1, B is 0, and C is negative 4. And before we have expanded double brackets. So you get a quadratic when you have two factors written like, let's say for x squared minus 4. Now, this is a special one that we've looked at before, and it's called a difference of squares, right? So the reason it's a difference of squares is because x squared is a square number, well, a square term, since x times x gives me x squared. And 4 is also a square number because 2 times 2 is 4. Right? So I just want to show you the relationship, right? So like x squared minus 4, known as a difference of squares, can be written as a product of its two factors, which we've done before. So x squared minus 4 will be x plus 2 as one factor by x minus 2. I call these two factors of x squared minus 4 because if I multiply these brackets out, I will get back x squared minus 4. And that's what factors are. When you multiply two factors by each other, you're supposed to, well, the two respective factors, that is, not just any two factors. But when you multiply those two factors, you should get back your original term, right? So for example, the factors of 6, the factors of 6 are 1, 2, 3, and 6. And if I multiply 1 times 2, I'll get back 6. If I multiply 2 times 3, I'll also get back 6. So I can write 6 as a product of its factors using brackets like this. 6 is equal to 1 times 2, or 6 is equal to 2 times 3, right? These are the factors of 6 because when I multiply them by each other, I get back 6. And it's the same thing with a quadratic expression. If I multiply these brackets out, I'm going to get back x squared minus 4. Look, it'll be x times x, which gives me x squared. X times negative 2 gives me minus 2x. And then 2 times x is 2x, and 2 times negative 2 is minus 4. And then what happens here is that you'll get x squared minus 2x plus 2x will cancel out each other. So you'll just end up with x squared minus 4. See? So that's why before we started to factorize the quadratics, we looked at uh, the algebraic factors. So we looked at three main things before we reached here. We looked at multiplying double brackets. We looked at algebraic factors, and we also looked at factorizing by grouping. And all of that plays a role in factorizing quadratics. So it is important to know how to identify A, B, and C in factorizing quadratics, and also just in general, when we start to solve the quadratic equations, and you're using the quadratic formula, you need to know what is A, B, and C as well, right? So let's just take a little recap on how do you factorize a pair of quadratics, sorry, not a pair of quadratics. How do you factorize a quadratic when, hold on, when A is 1? Right? So when A is equal to 1, let's look at some examples. Let's say I had x squared plus 5x plus 6. In this quadratic, A is 1 because it's just x squared, so that's 1x squared. B is 5 and C is 6, right? So let me just write that here. A is 1, B is 5, and C is 6. So to factorize this quadratic, when A is 1, it's quite simple. All you need to look at is what C is, and then you list the factors of C. So the factors of 6 are, I like to list them in pairs what that multiply to give you back 6, right? So if I'm listing them in pairs, it'll be 1 and 2, and not 1 and 2, sorry. It will be 1 and 6 because 1 times 6 is 6, and then 2 and 3. And I have to choose the two factors here that when you add or subtract them, they give you B. And at the same time, well, we already know that the pairs are written already in the form that when you multiply them, they give you back 6, right? So the two factors here that would multiply to give you 6 and at the same time add or subtract to give you 5 is 2 and 3 because 2 plus 3 is equal to 5 and then 2 times 3 is equal to 6. So those are the factors that I would use. Now I write it in the factor form. So that would be x plus 2 by x plus 3, right? We did this last week. I know we did. I'm just giving you a little refresh, okay, before we move on. So not all the time would all of the terms have positive signs. You can actually have one like x squared plus, sorry, minus 7x plus 12. Well, in this case, well, in all of these, A is 1, right? I'm going to do A when A is 1 first. So x squared minus 7x plus 12. Here it's interesting because you have as minus 7. B is not 7, B is minus 7. So A is 1, right? B is minus 7, and C is equal to positive 12. So I'm going to list my factors of 12. So that would be 1 times 12, right? 2 times 6 and 3 times 4. Those are all the factors of 12. Guys, this is also a systematic way, a strategic way of listing the factors. Don't just like, I mean, you can if you want. So it's not necessarily wrong. But of course, you want to use strategy in everything that you do. it makes sense to list the factors like this because one, it helps you to not miss any factors, right? So for example, I know that one and the number would always be will always be factors of that number. In the sense when it's a prime number, in the case when it's a prime number, those will be the only two factors. However, 12 is not a prime number. 12 is a composite number. So I know that it has multiple factors. I will start with 1, and I know that's going to pair with 12 because 1 times 12 is 12. Then I will move in numerical order. It is divisible by 2 because 12 is an even number. So I know that 2 is the next factor. So then 2 times 6 gives me 12. So 2 and 6 are the other two factors. And then finally, 3 can also go in 12, and 3 times 4 is 12. So I'll list it like that. That is a systematic way, a strategic way of thinking about the factors of C. Now, when A, sorry, is 1, it's simpler because we're only looking at C, right? In reality, as you would see as we go on today, it's really AC that you're looking at, right? It's really, you have to find AC, and AC is really A times C. But when A is 1, it'll just be C because 1 times anything is just that number. It's the identity element, right? So A times C here would be 1 times 6, which is 6. So you see, the C and C will be the same thing when A is 1. But sometimes in a quadratic, just like in this example here that I gave you, A was not 1, it was 3. And AC in this case would actually be 3 times 4, which is 12, right? So we'll move on to that just now. For the while, we're just looking at when A is 1. So you have three factors, your three groups here, 1 and 12, 2 and 6, and 3 and 4. I need to ask myself which of these two factors, when I add or subtract them, will give me -7, right? I know they already multiply to give me 12. So which of them will give me -7? As they are, none of them could give me -7 unless I change the signs, right? To get -7, I would have to choose 3 and 4 because if you have -3 minus 4, well, that would give me -7. And at the same time, -3 times -4 is +12 because two negatives multiply to give a positive. So my factors in this case will actually be, you're going to have x minus 3 by x minus 4. Those would be the factors. X minus 3 by x minus 4. And last week when we were going through this, I was telling you guys, once C is positive and B is negative, the two factors have to be negative, right? It would not be where one of them is positive and the other one is negative. They will have to be positive. So when you have a positive C value, right? No matter what, the two factors will always have the same sign. Either they will be both positive, like in this example 1, where it's 2 and 3, +2 and +3, or they will both be negative, as in this example here with number 2, where it's -3 and -4. So once C is positive, you're going to have two factors with the same sign, both adds or both minuses. Okay, guys? Let's look at another one. Let's say in this one, we have x squared plus x minus 12, right? In this one, as you can see, C is negative, right? So when C is negative, think about it, right? Remember the factors, it's multiplication, right? So it means that the two factors have to have different signs because in order to get -12, you either have to have, so let's list the factors. They are 1 and 12, 2 and 6, or 3 and 4. But if it's negative, it would either have to be -1 and +12 or 1 and -12. It'll have to be -2 and +6 or 2 and -6. And then finally, it would have to be -3 and +4, right? Or um or 3 minus 4, right? That's how it would have to work because in order to get negative 12, it would have to be negative 1 times 12, which is negative 12, or 1 times negative 12, which is negative 12, or negative 2 times 6, or 2 minus 6, negative 3 times 4, or 3 times negative 4. So I need to get in this one, A is 1, B is also 1, and C is negative 12. So from the factors here, that would, all of them I know would multiply to give me negative 12. But the one that would add to give me positive 1 will be when 3 is negative and 4 is positive, because negative 3 plus 4, negative 3 plus 4 is equal to positive 1. All right. So the factors here would be, this will be x times x minus 3 by x plus 4. There you go. Try this one for me, guys. Just to start. Try x squared minus 9x plus 20. X squared minus 9x plus 20. So your first step is to identify A, B, and C. Your second step is to find the factors of C that would add or subtract to give you minus 9. Well, to give you B, and at the same time multiply to give you 20. Try this one and try this one as well. Number 5. Send me your answers. X squared minus 4x minus 21. Try these two, please. Remember, first things first, you need to identify A, B, and C. So what is A, what is B, and then what is C? List your factors in a strategic way, right? So in pairs, meaning the two factors I would multiply to give you C. List it like that so that when you're looking at it, you can easily choose which ones will give you B when you add them. Tell me your answers. You should take no more than 3 minutes to do this. Okay, guys. So I'm gonna do it. I'm gonna do it with you guys. Firstly, in number four, A is 1, B is -9, and C is +20. The factors of 20 are 1 and 20, right? 2 and 10, and then 4 and 5. So as you can see here, the two factors that numerically can add up to give you 9 would be 4 and 5, but it's -9, right? So remember, they have to multiply to give me 20. So, and at the same time, add or subtract to give me -9. Now, if it wasn't negative, it'll just be +4 and +5. However, because it's negative, it's going to be -4 take away 5, because -4 take away 5 is -9, and -4 times -5 is +20. So my two factors, my two signs will be negative and negative. Remember, I just told you guys that, right? Once C is positive, the two factors will either both be positive or both be negative. Now, when C is positive and B is negative, the two factors will always be both negative. So you'll have two negative signs in your brackets. So this would be x -4 by x -5. Always, right? No matter what, that is standard because mathematically, that's just what makes sense. You could only get a positive number where you could only get if you have -4 by -5, you can get +20, and also +4 and +5 can give you +20. However, to get -9, they both have to be negative, right? So you could write that down, and I did make you guys write that down last week, where I told you once C is positive and B is negative, the two factors will always be negative, right? Then in number five, A is 1, B is -4, and C is -21. All right. So listing my factors, I would have 1 and 21 or 3 and 7. Okay. So here I need they have to give me -4, right? So it has to be 3 and 7 could give me 4, right? Because 7 take away 3 is 4, but I need it to be -4. So therefore, it would have to be 3 take away 7. Since 3 take away 7 is -4, and then 3 times -7 is -21. So once C is negative, guys, the two factors will have different signs, and it would just depend on which of them would give you minus. Will give you B. So the factors here would be x -7 by x plus 3. Okay, so not all the time. You can also have a quadratic when when A is actually -1. A could be negative. So let's look at when E is -1. What happens? So we're looking at when E is -1. I know we did this last week and I'm spending so much time on it, but it's really, it needed to be, I need you also to understand it. Okay, so let's say we had um, minus x squared plus 5x plus 6. When you have to factorize a quadratic in which A is negative, what you should do is factor out that -1 first. So if I were to factor out -1 out of this whole expression, I'll put -1 on the outside, and that would give me, well, -1 into -x squared will be x squared. -1 into 5x would be -5x, and -1 into +6 will also be -6. So if you notice what happens when you factor out the -1, what happens is that the signs of all the terms will just change, right? So like instead of -x squared, you'll now have x squared. Instead of plus 5x, it will be -5x. And instead of +6, it will be -6. So you'd use your regular rules now, your regular rules that we've been using all along. A is 1, B is -5, and C is -6. The factors of C would be either -1 and +6, or +1 and -6. And then it could be -2 plus 3, or it can be 2 minus 3. So based on this, we have to now choose which of them will give me -5. It's going to be 1 minus 6, because 1 take away 6 is -5. Remember, it has to add or subtract to give me B, which is -5 in this case. So I'm going to write the factors within the square brackets. I'm keeping -1 on the outside. And in brackets, I'll have x plus 1 by x minus 6. And now finally, I'm going to remove the brackets. I'm going to multiply -1 throughout. And if I multiply by -1 throughout, the signs inside will also change. So this will give me 1 minus 1 times, will be minus x, and -1 times +1 will also give me -1. So this will be minus x -1 by x minus 6. So I can write this here as -1 plus x by x minus 6. Oh wait, sorry. I forgot to change the signs in the second one, guys. I forgot to change it here. By the way, it's acceptable. Let me just write this out. It's acceptable to write this just as -1 by x plus 1 by x minus 6. You can leave it just like that, and that would be fine. Right? You don't necessarily need to write it otherwise. Let's look at another one. Let's say we had when a is -1 minus x squared minus 3x plus 10, right? So I'm factoring out the -1 on the outside. So inside, I'm just going to change the sign of all of these, because if I divide by -1, each term in here by -1, all these signs will change. I'll end up with x squared plus 3x minus 10. And I use my regular rules that we've been using all along. I use A is equal to 1 to identify A, B, and C. B is 3 and C is -10. So the factors of -10 will be -1 plus 10, or 1 minus 10. So -1 times plus 10, or 1 times -10. And then I could also have 2 and 5, right? So -2 and +5, or +2 and -5. One here, that would give me +3, because B is 3. It's going to be -2 plus 5, because -2 plus 5 is 3, and -2 times 5 is -10. Now I rewrite it in factored form. I'm keeping -1 on the outside. So it would be -1 by x minus 2 by x plus 5. That's my answer. I want you guys to try too for me. I'm leaving it on the same page so that you can have it for reference if you didn't write it down as yet. Try for me minus x minus 7x plus 18. And then also you're trying this is minus x squared plus 4x minus 3. You could leave it like in this form. You don't need to expand it by changing the signs. You don't need to do that. It's fine. Okay, guys, let's look at number 8. Number 8, remember, first thing that I told you to do is to factor out the minus 1, right? So factoring out the minus 1 will change the sign of every term in the quadratic. So this will end up being x squared plus 7x minus 18. Since minus 1 times x squared is minus x squared, minus 1 times 7x is minus 7x, and then minus 1 times minus 18 will give me plus 18. And now you look at the factors of C. So the factors of 18 are 1 and 18, and 18, 2 and 9, 3 and 6. Of those, the one that I could get 7 from will be 9 and 2, because 9 take away 2 is 7, and 9 times negative 2 will give me will give me negative 18. So this will end up being minus x. You can write 1, you don't need to, or you could just write the minus sign as well. That would be minus x, x in brackets, minus 2 by x plus 9. So the two factors will be minus 2 and plus 9. Then you have number 9, so let's remove the minus 1 by factoring it out. So that changes the signs of each term in the expression. So this will be x squared minus 4x plus 3. The factors of 3 are simply 1 and 3 because 3 is a prime number. So we got to use 1 and 3. To get minus 4, that would have to be minus 1 minus 3. Minus 1 minus 3 will give me minus 4. So in my brackets, it will be x minus 1 by x minus 3. Don't forget your minus or minus 1 on the outside there. If I wanted to like just write it out completely, guys, it would be without the minus 1 in front here. So if I were to multiply it out here, I would end up with, this would be minus x and minus 1. So you'll have minus 1 minus x by x um, minus 6. Yes, x minus 6. This one, you would have minus x plus 2 by x plus 5. This one, oh gosh, everything is so jumbled up now. I'm sorry. This one here will be minus x plus 2 by x plus 9. And this last one will be minus x plus 1 by x minus 3. Right? But you don't need to write it like that. You can if you want to, but it's not necessary. All right, we're going to take a short break just for until 5. So that's 12 minutes. Make sure you copy down the correct solutions if you didn't get it. And if you're struggling, please let me know. I want you all to write down for me these important points to remember. Okay? So steps, I'm going to recall the steps in factorizing the quadratic, and then I'm going to just write some points to guide you when you are choosing the factors. Because when all the terms are positive, it's easy to choose the two factors. But when the terms have different signs, I think that's where some of you are getting confused. So be mindful that if C is positive, the two factors will either be, the two factors will either both be positive or both be negative, right? So what I mean by that, I'm going to expect something like let's say I had, for example, let's say I had x squared, um, x squared minus 5x plus 6, right? The factorization here, the factors of this would be x minus 3 by x minus 2. So you see how I have minus and minus? Because minus 3 times minus 2 gives me positive 6, and then minus 3 take away 2 gives me minus 5. Or similarly, now if I had the same expression, except it was plus 5x plus 6, then the factors would both be positive, right? Because it'll be x plus 3 by x plus 2 plus 3, sorry, plus 3 by plus 2. So when C is positive, as in the case here, right? In this one, A is 1, B is minus 5, and C is positive 6. So the two factors, once B is negative, the two of them will be negative. Once B is positive, the two of them will be positive as well, provided that C is also positive, right? So once C is positive, the two factors will either be positive or both be negative. They'll be positive when B is positive, and they'll be negative when B is negative, right? So in this case here, in this first case here, right? A is, well, we don't need to study what A is. We need to study what B is. So C is positive and B is negative. So when C is positive and B is negative, the two factors will both be negative. Two factors are both negative. So this is something, just a little note for you to jot down, right? In this case here, right? In this case, B is positive. Let me write out the word. B is positive and C is also positive. So the two factors will be, both of them will be positive. As you can see, plus 3 and plus 2. So please make a note of this. If you find yourself getting confused um with the signs. Okay? Now, if C is negative, the two factors will have different signs, meaning one will be plus and one will be minus. So an example of that is let me write that down as well. Right, so another thing, right? If if you didn't get a chance to write this down, don't worry. I'm gonna send it to you afterwards, okay? Just leave out some space. Right, so if C is negative, if C is negative, two factors will have different signs, no matter what. One will be positive and one will be negative. The two factors will have different signs, regardless of if B is positive or negative, they'll still have different signs, right? So like when C is positive, the two signs will be negative. The factors, the two of the signs will be negative if B is also negative. But when C is positive and B is positive, all of them will be positive, right? However, if C is negative, the two factors will have different signs regardless of what B is. So for example, if I had x squared plus x minus 12. The factors here, sorry, a, b, and c. Well, a is 1, b is 1, and c is negative 12. So once c is negative 12, I know in my brackets, I am going to have plus something, x plus something, and x minus something, right? So now you just have to choose the factors. So the factors are 1 and 12, 2 and 3, or not 2 and 3, sorry, 2 and 6. 1 and 12, 2 and 6, or 3 and 4. So from these, the combination, and I could get 1 because I need to get positive 1, it would have to be 3 and 4 because 4 take away 3 is 1. So that means I'll have plus 4 and minus 3. Plus 4 times minus 3 is minus 12, and 4 take away 3 is 1. So regardless of what B is, once C is negative, the two factors have different signs, always, right? So another example might be like if we had x, like in the this is from the exercise we just looked at. If you had x squared minus 4x minus 21, notice in this one B is negative, right? So here B is negative 4 and C is negative 21. Already, because C is negative, I know that in my factors, I'm going to have x plus something and x minus something. It's just how it goes, right? So your factors are 1 and 21 or 3 and 7. So to get negative 4 from 3 and 7, it must be 3 minus 7. It can't be 7 minus 3 because 7 minus 3 is positive 4, but I need negative 4. So in my brackets, I'll have x plus 3 by x minus 7. So just like when you're doing your questions, make sure that you're thinking actively about what you're doing, right? So you're looking for certain things. One of the things that you're looking for when you're factorizing is you're looking to see if that C is negative, because in your mind you're already thinking, okay, once I know C is negative, the brackets are going to have different signs. When C is positive, I know the brackets are going to have the same sign, right? So let's move on now to when A is greater than 1. All of the examples that we have done so far, A was equal to 1 or negative 1. But now we're going to look at when A is greater than 1. So the first example would be, say we had 2x squared plus 7x plus 3. So in this one, guys, I need you to pay close attention to this because we're going to do factorizing by grouping in this one, right? Now, here, we need to identify A, B, and C, right? So A, B, and C. A here is 2, right? B is 7, and C is 3. So unlike the others, when I was just looking at C, when A is greater than 1, right, you have to look at AC. So AC here, AC is equal to 2 times 3, which is 6. AC literally means whatever A is, multiply by whatever C is. So AC is 6. And now we're going to follow the same rules. What are the factors of 6? The factors of 6 are 1, and 6 and 2 and 3. And you ask yourself, which of these pairs will add to give me 7, right? So it's obviously going to be 1 and 6 because 1 plus 6 is 7 and 1 times 6 is 6. So what I'm going to do now is I'm going to rewrite the expression, but instead of 7x, I'm going to write it as 1x plus 6x. So x plus 6x, right? So this will be 2x squared plus x plus 6x plus 3. So it's the same expression. I'm just writing 7x as the sum of the two factors I chose, which is 1 and 6. So that's 1x plus 6x. And now I'm factorizing by grouping. So if you guys recall, factorizing by grouping means you factorize the first two terms here and then the second two terms, right? So you're looking at what is common between 2x squared and x squared. The common factor there is x. So x into 2x squared is 2x, and then x into x is 1, right? You bring down this plus sign. The common factor between 6x and 3 is 3. 3 into 6x is 2x, and 3 into 1 is 1. So as you can see, I have my repeated factor. So that's the first one, 2x plus 1 and x plus 3. So that's how I would factorize 2x squared plus 7x plus 3. So instead of just looking at C, you need to first, right? So first we needed to, first step one was to, well, identify A, B, and C, right? And then you find AC by multiplying A by C, right? And then you're going to ask yourself what two factors, what two factors of AC will add add or subtract to give E, and at the same time, and at the same time, multiply to give me AC. So before it was just I mean it was AC as well, but A was 1. So it would just be whatever C is, right? And give B and multiply to give AC. Right? And once you choose your two factors, you're gonna rewrite the expression replacing E EX with those two factors, and then you factorize by grouping. Right? So third, rewrite the expression, rewrite the quadratic, rewrite quadratic, replace then EX as the sum, I should say expressing EX as the sum of the two factors, sum or difference of the two factors you chose. Instead of writing, we're replacing and represent the same. And then finally, you will factorize by grouping. That's how you factorize a pair of not, I don't know why I always say a pair. I just always think of simultaneous equations in my head. Yes, this is how you factorize a quadratic expression in which the A term is greater than 1. Let's do another one. Let's do, mm, let's say I have 3x squared plus 10x plus 8, right? So first things first, I identify A, B, and C. Well, I should have actually put that as the first, but let's just say A is 3 and C is 8. So A is 3, E is 10, and C is 8, right? So AC here will be 3 times 8, which is 24. And listing my factors of 24 in pairs already, you'll have 1 and 24, you'll have 2 and 12, you'll have 3 and 8, and you have 4 and 6. All of them are positive. So the group here that would give me 10, the pair, sorry, that would add to give me 10 would be 4 and 6. 4 plus 6 is 10. And 4 times 6 is 24. So I'm going to rewrite the expression, replacing x with those two factors, 4 and 6. So this will be 3x squared. Now I can write 10x as 3x squared plus 6x plus 4x. plus 8. And now I go ahead and I factorize by grouping. The common factor between 3x squared and 6x is 3x. So 3x into 3x squared is x, and then 3x into 6x is 2. Between 4x and 8, oh, just bring down this plus sign. Between 4x and 8, the common factor is 4. 4 into 4x is x, and 4 into 8 is 2. So this will give me x plus 2 is my repeated factor multiplied by 3x plus 4. So my factors there would be x plus 2 by 3x plus 4. And it doesn't matter what order you write it in, because it's multiplication. So x plus 2 by 3x plus 4 is the same as 3x plus 4 by x plus 2. So it really just depends on how you rewrite the bx. That would determine which factors you'll put first. So another one. All right. So we're looking now at, let's say I have 4x squared plus 12x plus 9. All right. The We need to identify A, B, and C. A here is 4, right? So A is 4, B is 12, and C is 9. So I already know C is positive and B is positive. So I know the two factors, both going to have pluses, right? So first thing, I find AC. AC is 4 times 9, which is 36. Now I list my factors of 36, making sure to list it in the pairs that would multiply to give me back 36. So that will be 1 times 36, 2 times 18, 3 times 12, 4 times 9, 6 times 6. I think that's it. I don't think they have any more. Right? So the pair here that would add to give me 12, right? Because it has to add to give me 12. It's going to be 6 and 6, because 6 plus 6 is 12 and 6 times 6 is 36. So I'm rewriting my expression, replacing 12x with 6x plus 6x. So let's go. So this will be 4x squared plus 6x plus 6x plus 9. Right? So this gives me, I'm going to factorize by grouping now. Between 4x squared and 6x, the highest common factor is 2x. 2x into 4x squared is 2x, because 2x times 2x is 4x squared. And then 2x times 3 gives me 6x. So this will be 2x plus 3. And now this plus sign. Between 6x and 9, the common factor is 3. 3 into 6x is 2x, and 3 into 9 is 3. So I have my repeated factor, same terms and same signs. So that's 2x plus 3 by 2x plus 3. That's how I will factorize 4x squared plus 12x plus 9. Let's do another one together. Let's say we have 5x squared, 5x squared plus 13x plus 6, right? So A, B, and C. A here is 5, B is 13, and C is 6. So AC then will be 5 times 6, which is 30. And listen, the factors of 30 in pairs that would multiply to give me back 30 will be 1 and 30, 2 and 15, 3 and 10, and then 5 and 6. So the two factors there that would add to give me 13 will be 3 and 10. Okay? So now I'm going to rewrite the expression replacing 13x with 3 and 10. So that would be 5x squared plus, I'm going to put 10x here because I know that 10 and 5 have a common factor, right? So plus 10x plus 3x plus 6. And now I factorize these first two terms. That would be 5x is common here. So 5x into x plus 2. Bring down this plus sign. The common factor between 3x and 6 is 3. So that's going to be 3 by x plus 2. Now I have my repeated factor. I have x plus 2, right? 5x plus 3. Okay, guys, I want you all to try one for me, please. Please try this one. Please try number 5, which is 2x squared plus 9x plus 10. Everyone, try this one for me. Please send me your efforts. Anything as yet? Please let me know what's going on. Right, so A, B, and C. Here, A is, okay, I'm gonna write this over. Just gonna put this on the other side. So I have a little more space with. Oh, what happens? Draw a little line to separate them. Good. So in this one, 2x squared plus 9x plus 10 is 2. B is 9 and C is. So AC will be 10 times 2 or 2 times 10, which is 20. And my factors of 20 listed in pairs that would multiply to give me 20 would be 1 and 10, 2 and, sorry, 1 and 20, sorry, 1 and 20, 2 and 10, and 4 and 5. So of those, the factors that would add to give me 9 will be 4 and 5. So those are the factors I'm going to use. So now I'm going to rewrite the expression, replacing 9x with 4x plus 5x. So that would be 2x squared plus 4x plus 5x plus 10. So factorizing by grouping, the common factor between 2x squared and 4x is 2x. 2x by x gives me 2x squared, and 2x by 2 gives me 4x. Bring down this plus sign. The common factor between 5x and 10 is 5. So 5 into 5x is x, and 5 into 10 is 2. So this will be x plus 2 by 2x plus 5. So if you got that, very good. If you didn't, I hope you saw where you went wrong. I am going to message those of you who I didn't get any work from afterwards to find out what's going on, right? Because I want to make sure that you're on the right track. I'm getting work from the same people right through. I need to see work from all of you. All right, so guys, in all of these examples so far, C was positive, B was positive, A was positive. But that may not always be the case. Just like with the previous examples, you had like different signs for them. You can have different signs when A is greater than 1 as well. So let's look at some when A is greater than 1 and you have different signs. So uh, um, which number is this? This is 5? No, this is 6. So let's see. We have here 6x squared plus x minus 2. All right. So here, A is 6, B is 1, and C is -2. Remember, just a few slides ago, I told you once C is negative, the two factors will have different signs, no matter what. It's going to be two different signs because to get -2, it has to be, well, to get minus AC, you would have to have a positive by a negative because only when you have multiplication with two different signs can you get a negative product. So A, B, and C we have identified. AC is going to be 6 times -2, which is -12. So my factors of -12 written in order will be written in pairs that multiply to give me -12. Well, it could be 1 times -12 or -1 times +12. It could be 2 times -6 or -2 plus 6. It can be 3 times -4 or -3 times +4. So it's always going to be different signs. All right. Now the factors there, the pair that would give me 1, +1, will be 4 take away 3 or -3 plus 4. All right. So I am going to rewrite my expression just as I've been doing, replacing plus x with minus 3x plus 4x. So this will give me 6x squared minus 3x plus 4x minus 2. And now I factorize by grouping between 6x squared and 3x. The common factor, the highest common factor is 3x. I'm going to take 3x on the outside. 3x into 6x squared is 2x. And 3x into minus 3x will be minus 1. Bring down this plus sign. Between 4x and 2, the common factor is 2. So take 2 on the outside. 2 times 2x is 4x, and 2 times minus 1 is minus 2. So you see I have the same repeated factor with the same sign. This will give me, finally, 2x minus 1 by 3x plus 2. Right? So like I said, not all the time will you have same, all of them being positive, right? Sometimes you could have a negative and a negative C, right? Or even, well, any combination of signs. Let's look at another one. Say I have um 3x squared minus 5x minus 2. So let's identify A, B, and C. A is 3, B is -5, and C is -2. Notice that A, B, and C will take the term in front, the sign front of it, right? So like 5, it's not going to just, B is not just 5, it's -5. And C is not just 2, it's -2. So let's identify AC. AC here is 3 times -2, which is -6. So the factors of -6 written in pairs that multiply to give me -6 will be 1 times -6 or 6 times -1. 2 times -3 or 3 times -2. And that's it. Yeah. 1 and 6 or 2 and 3. So now we're looking for the two factors that when you add, well, when you add or subtract it, it gives you -5. You can see it's going to be 1 take away 6 because 1 take away 6 is -5. So I'm rewriting my expression, replacing -5x with my 1x minus 6x. So this will be 3x squared minus plus x minus 6x because it's 1 minus 6. So it'll be +1 minus 6 minus 2. And now I factorize by grouping. 3x squared and x have x in common. X into 3x squared is 3x, and x into x is 1. Bringing down this minus sign here. Between 6x and 2, the common factor is 2. Minus 2 times 3x will give me minus 6x, and minus 2 times plus 1 gives me minus 2. So I have my repeated factor, that's 3x plus 1 by x minus 2. There you go. Try one for me, guys. Try for me. I'm gonna put this underneath here, right, as part of that question. You are trying for me now. You're trying, this is number 8. Try 7x squared plus 2x minus 3. Yeah, try that one. Actually, try 2 for me. Try 7x squared plus 2x minus 3. And then try as well, it's x squared minus 6x minus. Just a hint, in all of these, the two factors will have different signs because C here is negative. That means if C is negative and E is positive, C will be negative. So these two factors will absolutely be positive. One will be positive and one will be negative. So just to recall your rules, you have to find AC, then list your factors of AC that would multiply to give you AC, and at the same time add or subtract to give you B. Sorry, I needed to start back recording. Yeah, as I was saying, guys, number 8 doesn't make sense, right? The reason it does not make sense is because, well, A here is 7, sorry, A is 7, E is 2, and C is negative 3. This is my fault, guys. I should have worked this out before I put it on the screen, but I'm just taking it from a worksheet, right? It's only now that I looked at it, I'm like, wait a minute, this doesn't make sense. So AC here will be negative 21, right? Because AC is um 7 times negative 3. So AC is negative 21. But the factors of 21 are really just 1 and 21 and 3 and 7. And none of these two combinations here could give me B. So this does not work. You know what would work? If instead of 2x, I had 4x, right? That would work. Because I could say, oh no, actually, yes, that would work because 3 times um 7 minus 3 times 7 will give me negative 21, and then minus 3 plus 7 will give you 4. So you'd have to change that 2x to 4x instead. I'm so sorry. I'm so sorry that I did not recognize that. I wish somebody had told me that you were struggling with number 8. So now it can be factorized because this will be 7x squared. Uh, 4x can be written as plus 7x minus 3x is 7x minus 3x is 4x, and then minus 3. In your factorization here, this between 7x squared and 7x will be 7x, the common factor. 7x times x gives me 7x squared, and 7x times 1 gives me 7x. And then here, minus 3 is the common factor. Minus 3 by x is minus 3x, and minus 3 by plus 1 is minus 3. So this will be your factors. Will be 7x minus 3 by x plus 1. Or x plus 1 by 7x minus 3. But that previous one, right? This previous one here, it was 7x squared plus 2x minus 3. It's cannot be factorized. Okay, so not all quadratics can be factorized, girls. Sorry, girls and boys. I forgot I have a mixed class. Yes, not all quadratics can be factorized, and that previous one could not have been factorized because none of these factors of 21 can add or subtract to give me positive 2. So the question itself had an error. And this is why you must double check everything that you get from ChatGPT, because I just got a worksheet from ChatGPT and I didn't even work out the questions myself as yet. I just assumed that the questions were correct, right? And they have a solution as well. They have solutions to these questions. So oftentimes I have found myself having to correct ChatGPT. So guys, ChatGPT sometimes gets it wrong. All right. Number 9, 8x squared minus 6x minus 2. So this will be 8x squared minus 6x minus 2. We have AC. Hopefully this one could factorize. Let's see. A is 8, B is negative 6, and C is negative 2. So AC here, AC is 8 times negative 2, which is negative 16. The factors of negative 16 that will multiply to give me negative 16 will be 1 and minus 16, or 16 by minus 1, 2 and minus 8, or 8 by minus 2. Yep, this works because 2 minus 8 gives me negative 6. So I can rewrite my expression placing negative 6x with 2 minus 8. So this will be 8x squared minus plus 2x minus 8x minus 2. And now I factorize by grouping. Common here would be 2x. So 2x into 8x squared is 4x. 2x into 2x is 1. Bring down this minus sign. 2 into minus 8x is 4x. And 2 into minus 2 is plus 1. See, I have my repeated factor. So my factors here would be 4x plus 1 by 2x minus 2. All right. So guys, this is how you factorize quadratic expressions. The key, you have to find AC. When A is 1, it'll just be C, right? But find AC. Ask yourself what two factors of AC will add to give B and multiply to give AC. Rewrite the quadratic, replacing BX as the sum of the two factors that you chose, and then factorize by grouping. Y'all, if you found that this gave you a little trouble, please rewatch the recording, see if it makes any more sense. If it doesn't, I have videos on YouTube on the same topic, which I will upload to the Google Classroom. But if you just go on the YouTube channel, you'll find them as well. So I'm going to send you guys these notes as well as the class recording. If you had trouble, please let me know. All right, so we're gonna stop class here for today, guys. I will see you all next week.